The universe is a stage of unimaginable scale, where galaxies collide and mysteries unfold in the darkness. In this vast expanse, some cosmic events become legends, etched across time and space, none more so than the Bullet Cluster, a cosmic crime scene 3.8 billion light-years away. For decades, it has been our most compelling evidence for dark matter, the invisible force sculpting the universe's fate. Now, on June 30th, 2025, NASA's James Webb Space Telescope has turned its gaze to this legendary cluster. The result? An image of breathtaking detail, unveiling secrets hidden for billions of years. This isn't just a prettier picture, it's a leap in our understanding of the universe's invisible architecture. The Bullet Cluster is the aftermath of two colossal galaxy clusters colliding at unimaginable speeds. Webb's near-infrared vision pierces cosmic dust, revealing thousands of background galaxies. Their light is bent by the cluster's gravity, a phenomenon called gravitational lensing. By mapping these distortions, Webb gives us the clearest picture yet of both visible and invisible mass. We're moving from a blurry sketch to a high-definition map, tracing the distribution of mass and testing our theories about dark matter on the grandest scales. For nearly a century, astronomers have known something was missing. The stars and galaxies moved too fast for visible matter alone to hold them together. The only explanation, a vast unseen scaffolding dark matter. The Bullet Cluster is the smoking gun. When the clusters collided, hot gas slammed together and slowed down while galaxies and dark matter sailed through. This created a clear separation. Hot gas lags behind, but the bulk of the mass, traced by gravitational lensing, moves ahead with the galaxies. Webb's new observations confirm this with stunning precision. The gravitational heart of the cluster aligns with the galaxies, not the gas. Direct evidence for dark matter. If dark matter interacted with itself, we'd see a drag or smear in the collision, but Webb's data shows none. Sang-Jun Cha, the study's lead author, says their careful measurement confirms dark matter is even more elusive and non-interactive than imagined. This deepens the mystery but solidifies dark matter's place in our cosmological model. By observing its behavior here, we can place tighter constraints on its properties. The Bullet Cluster remains the clearest window into the invisible universe. Webb's precision brings us closer to understanding what holds the cosmos together. How do you map what you can't see? Einstein showed us. Gravity bends space-time. Massive clusters like the Bullet Cluster act as cosmic lenses, distorting the light from galaxies behind them. Webb's sensitivity lets scientists identify thousands of faint, distant galaxies, measuring their shapes to map the cluster's mass. The result? A detailed mass map showing peaks of density that align with galaxies, not hot gas. Webb also maps the faint intra-cluster light, stars stripped from galaxies, now tracing the dark matter halo. This ghostly glow is a powerful new tool for mapping dark matter. Previous telescopes gave us blurry outlines. Webb delivers sharp, granular detail. As co-author James G. notes, Webb's images let us estimate the cluster's mass, but future observations will refine the picture. Already, the data reveals a complex, elongated mass distribution, hinting at a more dramatic collision history. We're not just seeing where dark matter is, we're beginning to understand its story. Webb's vision is transforming our cosmic map. No single telescope can tell the whole story. Webb's near-infrared view is just one part of a cosmic symphony. Combined with Chandra's X-ray vision, which reveals the hot gas, we get a complete picture: galaxies, gas, and dark matter, each mapped in a different color. This multi-wavelength approach visually separates the cluster's components, showing how they interact and diverge. The research is a global effort, uniting NASA, ESA, CSA, and scientists worldwide. Hubble's early images laid the groundwork. Webb and Chandra now add depth and clarity. Each telescope builds on the last, creating a layered narrative of cosmic collision. Together, they reveal the universe's complexity and the power of collaboration. With Webb's detailed mass map, we can refine the Bullet Cluster story. The collision wasn't a simple head-on crash. Webb reveals asymmetries and elongated structures in the dark matter. This suggests a glancing blow or a chaotic history of multiple mergers. By studying the debris, galaxies, gas, and dark matter, we reconstruct the cosmic event. The elongated halos may mean the clusters are being pulled back together, destined to merge into a supercluster. Webb's refined map of intracluster light shows it's a reliable tracer of dark matter even in violent environments. This gives astronomers a new way to map dark matter in other clusters. The Bullet Cluster is now a laboratory for testing our models of cosmic evolution. Webb's revelations are just the beginning. We've moved from knowing dark matter exists to mapping its structure with confidence. The next leap comes with NASA's Nancy Grace Roman Space Telescope, launching in 2027. Roman will survey vast swaths of sky, discovering thousands of clusters and mapping dark matter on a grand scale. Webb will provide detailed follow-ups on Roman's discoveries. This synergy will revolutionize cosmology, letting us test how typical the bullet cluster is and refine our models. The study of the bullet cluster is about more than one object. It's about our place in the cosmos. Each new image is a step in humanity's journey to understand the universe. With Webb and Roman, we're piecing together the grand story of the cosmos. The ghost in the machine is coming into focus, and the view is magnificent.